I do this example yesterday? Yes. Condensing is when we put it back together. Have I done a condensing example yet?
I don't think so.
Okay. So let's go to this one. So I want to do one more expanding problem before I do a condensing. So expand, break apart these logs as much as possible. Remember, you have to write the log base A each time. Make sure your base looks like a subscript. Sometimes people have a tendency to write things like this and then they get very confused later on. So your base is a subscript. When I look at this, we have things being multiplied. How do we break those apart? So we would have log base A of x plus log base A of the square root of x squared plus 1. There's actually more we can do here, though. I don't know what it would be. A square root is the same thing as saying a power of 1/2. And if you have a power, where can you bring that? To the front. So we have log base A of x plus 1/2 log base A of x squared plus 1. Do we have a rule for breaking apart addition? No, so we're done. Why can't I bring this square down? It's inside the parenthesis. It's not the whole parenthesis squared, it's just one thing in the parenthesis. So I can't bring that exponent down. This is as simplified as it will go. Let's look at B. How many different logs will I have to have this time? 3. The top has 2 things multiplied, so each of those will get a log, and the bottom is divided by something, so that one's going to get a log. Can I do everything in one step? I don't have a base written, so you can just leave that off. It's assumed to be 10 if we don't write it, so it's log of x. This was times, so we put plus the log of x plus 2. Can you break apart the x plus 2? No. Divided by, for a division, we put minus log of x plus 3, but it was squared, so we put a 2 in front of that log. I want you guys to do C. See, it's a minor mistake that I'm seeing. So this square root of x squared plus 1, that's like what kind of exponent? 1/2. So we can bring the 1/2 down. Log base A of x squared plus 1. Everybody's good with that?
Yes.
Okay. Minus the x cubed. So what would I put there? Okay. Here's the problem. All of this is on the bottom, right? So you guys broke apart this and said, well, they're multiplied, so I need to add for log base A of x plus 1.
And it's not that? It's
Well, since it's on the bottom, if you distribute that negative, you have minus 3 log base A of x minus 4 log base A of x plus 1.
Wait. I
Okay.
get that.
Anything, so you do the log of the top and you have to subtract off the bottom. So since both of these are on the bottom, I have to distribute that negative to both. Okay, or you can just think anything that's on the top of the fraction will have a plus in front of it, anything that's on the bottom will have a minus in front of it. Another way to think about it is if you were to bring this up to the top, it would have an exponent of -4. so it has a negative in front of it when we break them apart. Is that okay with everybody? I'm gonna skip the next one. Let's go on and condense this time. So condensing or rewriting as a single log, we are gonna put these back together. And really all we're practicing with this is using these properties of logs because they're going to be important when we solve equations with logs in a few sections. So that's all we're really doing right now. When I combine these, they're all log-based 4. So here's what you need to look at. Anything that's positive will go on the top, anything that's negative will go on the bottom. Okay, it doesn't really matter what order they're written in. So we have a log-base 4 of x, so I have an x. Minus means divide. I log base 4 of y, so divide by y. Then this one is plus, so where does the z go? Back on top. So it's log base 4 of x times z divided by y. What is that sound? Do you guys even hear? Mm-hmm. It's annoying me, but
Oh, I
Is
hear
it
it.
outside?
Wait,
I do not hear anything.
Wait, you guys sound
I think
like
it's a phone.
everybody silent, 3, 2, 1.
It sounds like an alarm going off.
I don't hear it.
Silence.
Okay.
you really don't hear that?
I think it's outside.
I mean, is it like really driving me nuts?
Somebody turned their phone off. They're getting a call.
Is it the water fountain on
I
the wall?
lied.
Wait, is it like
It
the?
was a lie.
Oh,
It was a pink phone. I pressed the power button and it turned off.
okay, thank
Oh, that's
you.
mine.
Taylor, what were you doing?
Wait,
I
I
don't
did not.
know.
Wait, I think we heard something different because I didn't hear a phone.
See,
I heard
I
like
knew
the water
the entire
fountain
time
running.
what was going on.
Just look
Wait.
at it and see what happens.
There's nothing
It's
wrong
not
with
It
happening.
quit.
Yeah.
Okay,
Anyway,
I feel better
next
now.
to it, I thought it was mine.
Bonus points for me.
My bad.
I
I don't know what
Taylor.
happened with my phone.
We're gonna snack your phone.
Sorry.
All right, so if I look at this one, what would I do with the 4?
Exponent.
Yep, that's an r to the 4th. The 5 is going to make an s to the 5th, and what am I doing with these?
Dividing.
So log base b of r to the 4th divided by s to the 5th. All right, one more. So this 1/3 would turn into an exponent. The 2/3 turns into an exponent. So we have log base a. These are added, so when I put them together, they are multiplying. Minus, so that means divided by xy. If I told you, could you simplify this at all? Yeah, if you have x's on top and bottom, what do you do with their exponents? Subtract them. Where will it end up, on the top or the bottom? What's bigger, 1/3 or 1? 1. So 1 minus 1/3 is 2/3. Why the 2/3 on top? Why the first on the bottom? So the y would end on the bottom as well. Y to the 1/3. So you might be able to simplify things a little bit once you put them together. Any issues with those? You guys do a couple. So just condense these for me. So the first one, you should have log base a, x times 9 times the x squared plus 1, or you could write 9x times x squared plus 1 divided by 5. If you wanted to distribute that, you can, or you can just leave it like this. B, you would have log base 5 of u to the third times v to the fourth. Are those okay? The last example I want to do from this section is just practice using these properties a little bit more, but in a different way. So I'm going to tell you that log base 10 of 7 is equal to 0.8451. So then I want to use that fact to find these answers. So log base 10 of 49. Any ideas how I could rewrite that log base 10 of 49? Is the same as 7 squared. Where would the 2 go? The front, if we use the properties of logs. And log base 10 of 7 is 0.8451. Okay, so if we plug that in, what do we get? 6902. All right. It's always entertaining. All right, how would I rewrite 70? 10 times 7. Then what could you do with those? We can do the property of logs and say that's log base 10 of 10 plus log base 10 of 7. Right, log base 10 of 10, I didn't give that to you in the directions, but we should know that. It's like saying 10 to what power equals 10? 1. So we get 1 plus 0.8451, so 1.845. Are these okay? So that's the new piece for today. I want to do a little quiz review before you work on your homework, if that's okay. We have a lot of time left. So I want to talk about what will be on this quiz tomorrow. It's going to cover sections 1, 2, and 3. So section 1 was the inverse stuff. So we had some, let's see. Decide if f of x equals 3x plus 9 and g of x equals 1/3 x minus 3 are inverses. There's really a couple different ways you could do this problem. Anybody remember or can think of one option? Yes. The actual definition, the way our book told us we need to do it, is do the compositions. Inverses should cancel each other. So f composed with g and g composed with f should both equal x. You have to check both, but if one of them doesn't equal x, is there any need to check the other one? No, because then we know for sure they're not inverses. So g is 1/3 x minus 3. If I plug that into f, so 3 times 1/3 is just x minus 9 plus 9, which is x. Not enough to say they are for certain inverses, but we're pretty confident now. Check the other way. So G composed with F. So we would have 1/3 times the 3x plus 9 minus 3. So we get x plus 3 minus 3, which is x. So these are inverses. If either one is not just a plain x, they're not inverses. What would be another option if you forgot to do this? Graph them. We know from their graphs they should be symmetric across the line y equals x. So we could look at the graph. Could we just find the inverse of one of them and see if it is the second one? Yeah, we also found inverses. Let's review that. So, all right, if I asked you to find the inverse, what was the first step? Instead of f of x, we wrote a y so that we could switch the x and the y. So it becomes x equals 4 over 2y minus 3. And then what do we do? We're going to solve for y. So you multiply over your 2y minus 3. I'm trying to solve for y, so I'll add over this 3x. And then we could divide by 2x. Final step, instead of y, we just put it back in function notation. So f inverse is 4 plus 3x over 2x. I would probably also ask you to do domains and ranges on this. We did domain and range of the function, domain and range of the inverse. Remember, the domain of the function is equal to the range of the inverse. If I look at my original function and I want to find this domain, we know that in a fraction, what can't happen? The bottom can't be 0. So x can't be 3/2. So my domain would be negative infinity to 3/2 union 3/2 to infinity. And that is the exact same as the range of the inverse. For the range of the original function, is it easy to look at it and identify the range? Not really, but we know the range of the function is the same as the domain of the inverse. So look at your inverse. For your domain, the bottom can't be 0. So x can't be 0. So these are negative infinity to 0, union 0 to infinity. This question would probably be worth a lot of points because there's, several steps to finding the inverse, and then all of your domains and ranges. Are there any questions on that? So that was section 4.1, all the inverse stuff. Section 4.2, the exponentials. So you should be able to graph any exponentials that I gave you. So if I said y equals log base 2 of negative x. We know parent functions and transformations. Oh, sorry, I said exponentials. This would be like section 4.3 with the log. Sorry, I meant to do it exponentially. How about 2 to the negative x? I got ahead of myself. All right, parent function is just 2 to the x. When we graph those, what 3 points did I tell you to plug in? So 2 to the negative 1 is 1/2, 2 to the 0 is 1, 2 to the first is 2. So that's my parent. What would a negative on my x do? Flips it over the y-axis. I'm trying to make my x's opposite. So it would look like this. Okay, so I might ask you to graph an exponential. Can we handle that? Plug in our 3 points and transformations as before. We also started solving exponential equations. So let's try a couple of those. Let's do So what could we do? Common base. 64 is the same as 4 cubed. You could also do 2 to the 6 would work. 16 is 4 squared. Make sure you write those in parentheses because now what do I have to do? Yeah, power to a power we multiply, so we get 4 to the 9x equals 4 to the 2x plus 10. So then you can set your exponents equal to one another. Subtract over the 2x. And we should get 10/7. And then we know we can always check those just by plugging them back into the original. All right, so common base problems. Are we good with that? So section 4.3 is what we have been working on with the logs. So we should be able to graph any. So let's say if I gave you y equals negative log base 2 of x. We still did the parent functions and transformations. My parent function is just your regular log. What did we do to these in order to be able to graph them? Yeah, we had to make a t-chart. We wrote it in exponential form. So when we make our t-chart, we're plugging -1, 0, and 1 in for the y because those are the exponents. So 2 to the -1 is 1/2, 2 to the 0 is 1, 2 to the first is 2. What would a negative out in front do to that? Going to flip it over the x-axis. So it should look like that. Is that okay with the graph on the log? Just change it to exponential, it's the same thing. Properties of logs, I'm not going to do any examples of that because you're doing it on your homework tonight. Then we had the log equations like we were solving yesterday, so let's try one or two of those and then I'm done with my review. So if I said, we really struggled with one the other day that had fraction, I believe. So let's say log base x of how would you solve this one? It's a good question. Yeah, change it to exponential. How do you get rid of a fifth power? Fifth root, do you need plus or minus for that? So what is the fifth root of 243 over 32? 3 halves. One more. We'll do one with a radical in it. Let's do... So I'm going to make it more interesting though. I don't want that to be an 8. Let's make that a 64. Okay, what would you do? Yeah, anytime we're dealing with logs, whether we're graphing them or solving equations, we always change them to exponentials first. So it'd be 8 to the x power equals the 4th root of 64. This is kind of like our exponential equations now. A 4th root is the same as what power? 1/4. So what's my common base going to be? 8. So 64 is 8 squared to the 1/4. 2 times a 4th is 1/2. So x is 1/2. Are we okay with this stuff? Know what to expect tomorrow? So, time to work so you guys can get this done.